so 8.1. Chapter 8 deals with sequences and series. There's two types of sequences and series that we're going to focus on. Arithmetic and geometric, which you may remember those from Algebra 2 or Geometry. But we're going to get into those more in detail in 8.2 and 8.3. So 8.1 is kind of just a broad sequences and series section. So a definition of a sequence, we can have an infinite sequence or a finite sequence. What do you think the difference between these two are? Infinite goes forever, so it's never ending. And finite has an ending. So an example of a sequence would be 5, 7, 11, 15, and we would do dot, dot, dot. So that dot, dot, dot means that it keeps going. 5, 7, 11, and 15 would be terms in our sequence. So each number is a term. This would be our first term, second term, third term, fourth term, and then it keeps on going. So that's just an example. So example 1, we are writing the terms of a sequence. Write the first four terms of each sequence. So n is the number of terms. So we plug in, if we have the first term, we plug in 1 for n. So a sub n, or a sub 1, because we're going to do the first term, is equal to 3 times 1 minus 2. So we plug in 1 for n. So 3 times 1 is 3. 3 minus 2, 1. Then we plug in 2 for n. So a sub 2 is 3 times 2 minus 2. 3 times 2 is 6. 6 minus 2, 4. A sub 3. We plug in 3 for n. So 3 times 3 minus 2. 3 times 3 is 9. 9 minus 2. 7, and then a sub 4, so we plug in 4 for n. 3 times 4 is 12, and 12 minus 2, 10. So our first 4 terms of our sequence are 1, 4, 7, and 10. Now on a test or quiz, I know that you guys can put this without showing any work. You can do it in your head. This isn't hard math, but I need to see all of this work in order to get full credit. So I need to see what you're plugging in. So even for the homework, you got to show me what you're plugging in to find each term. You got to write it out. Show me your work. All right, let's do the same thing for B. So again, we're plugging in 1, 2, 3, and 4. So a sub 1, we plug in 1 for n. So 3 plus negative 1 to the first power. What's negative 1 to the first power? So 3 plus negative 1, 2. Next, we plug in 2. What is negative 1 to the second power? Positive 1. And 3 plus 1? 4. Next, we plug in 3. So 3 plus negative 1 to the third power. What's negative 1 to the third power? Negative 1. So 3 plus negative 1, 2. And then we plug in 4. So it's negative 1 to the fourth power. Positive 1. So 3 plus 1, 4. So our first 4 terms of our sequence would be 2, 4, 2, 4. Any questions here? It's as easy as it looks. All you do is plug in whatever it tells you to. You just have to show your work. All right, example 3. We have to write an expression for the apparent nth term a sub n of each sequence. So we're coming up with the equation like example 1 gave us. So it gives us the first 4 terms. We have to come up with the expression. So my first 4 terms are 1, 3, 5, and 7. In the next couple sections, so 8.2 and 8.3, we're going to have formulas to help us come up with the expression, but for now we just kind of have to use our brains a little bit. So these are my first 4 terms. So I have term number 1, term 2, term 3, and term 4. What do I do to go from 1 to 3, 3 to 5, 5 to 7? What am I doing? I'm adding 2 each time. So add 2, add 2, add 2.
So would you write that as n plus 2?
No, because n is the numbers up top. These are our n's. So what if I add 2 to 4? Do I get 7? No. But if I add 2 each time, this would be like a linear relationship here. So what's the formula that I use for things that are linear? Y equals mx plus b. Yeah. What was that?
Never mind, I keep writing.
What is our slope? 2. 2 would be our slope. So we plug 2 in for m. Instead of x, we use n here because we're talking about our number of terms. And then what does b stand for? The starting point. But b is our y-intercept. That's when n is 0. Do I know when n is 0 here? No, but I can figure it out. I just have to go backwards. So if I add 2 each time, what do you think I have to do to go from 1 to the one before? Subtract 2. So what's 1 minus 2? Negative 1. So a sub n is equal to 2n minus 1. And then I can plug in any n here. If I plug in 1 into my equation, I'll get 1. If I plug in 2, I'll get 3. If I plug in 3, I get 5. If I plug in 4, I'll get 7. So these just require you to think a little bit. So that was A. Let's do B. So B, I start off with 2, 5, 10, and 17. So 2 is our first term, 5 is our second, 10 is the third, 17 is the fourth.
How did you get negative 1 again?
All right, for B, what do I do to get from one number to the next? What do I do here? Add 3. What about here? Add 5, and here? Add 7. So this is not linear. We're not adding the same thing each time, so I can't just do the same thing that I did the last time. So I gotta think a little bit.
The square root is n squared plus 1.
You're a genius. So Ryan said he noticed a relationship between n and the result. So he said if I square n and add 1 to it, that gives me these numbers here. So if I took 1 squared, that would be 1. Add 1, I get 2. If I did 2 squared, add 1, that gives me 5. 3 squared, add 1, that gives me 10. So this would be n squared plus 1. Awesome.
Is there a word you could show for that?
Like I said, for some of these you can do in your head. For these, it takes practice. The more that you see, like, the relationships start to, like, you'll see the same thing happen again and again, and it'll become easier to come up with the formulas. Some people, it just clicks. It's like solving a puzzle, like logs. But it just takes practice, because you'll start to see the same things happen over and over. All right, ready for the next example? So a recursive sequence, requires the number before in order to go to the next. So I can't just find like the 100th term without knowing what the 99th term is. So here it gives me a sub 1, and I have to write the first 5 terms of the sequence. So I know my first term is what? 3. That was given. Now a sub 2, I plug in 2 into k.
So K equals N. Or is it opposite?
Any questions here? We're going to skip example 5 and go to factorial notation. So again, you guys have probably seen this in Algebra 2. Factorial is that exclamation point. So if I have 5 factorial, this isn't just a loud 5. It's 5 times everything that comes before it. So this is 5 times 4 times 3 times 2 times 1. Which when writing this out, you don't have to write the 1 because 1 times whatever you're multiplying is going to be the same thing. So n has to be a positive integer. You can't take the factorial of a negative. And then also we have a special case where 0 factorial is 1. So that's important to know. 0 factorial is 1, and also 1 factorial is 1.
Are we gonna have to like know how to do this for the test?
It's the same thing as recursive,
Just minus 2.
but just minus 2. So you need to know the 2 numbers before. So a sub 0 is 1. What's a sub 1? 1. So next I'm going to find a sub 2. So I plug in 2 into all of my k's. So a sub 2 is going to be equal to a sub 2 minus 2, which is actually 0, plus a sub 2 minus 1, which is actually a sub 1. So I'm adding the first 2 terms before. This is a sub 0 plus a sub 1. So what's a sub 0 plus a sub 1? 1 plus 1, which is 2. So then to find a sub 3, I plug in 3 into all of the k's here. So a sub 3 is going to be 3 minus 2, which is 1. And then a sub 3 minus 1, which is 2. So a sub 1 plus a sub 2. So a sub 1 was 1. What was a sub 2? 2. 1 plus 2 is 3. Next, I'm going to plug in 4. So I plug in 4 into all of my k's. So this is a sub 2 plus a sub 3. So a sub 2 is 2 plus a sub 3 is 3. So 2 plus 3 is 5. Next I have a sub 5. So what do I add to find a sub 5? So I add the 2 before it, so 3 plus 5, which is 8. So So those are our first 6 terms. So 1, 1, 2, 3, 5, 8. So here we're writing the terms of a sequence involving factorials. Write the first 5 terms of the sequence given by a sub n is equal to 2 to the nth power over n factorial, beginning with n is equal to 0. So 0 is going to be our first one. We have a sub 0. This will be 2 to the 0 power over n, which n is 0, factorial. So what's 2 to the power of 0? 1. And what's 0 factorial? 1. And 1 over 1 is 1. Next, I want to find a sub 1. So I plug in 1 into all of my n's. So I have 2 to the first power over 1 factorial. Then you start with 1. Yeah, you usually start with 1 unless it says otherwise. So here it says begin with n is equal to 0. Sometimes it could tell you n is greater than 5. So then you would start with 5, 6, 7, 8. Yeah. So that's our first term here. So that's one answer. So when it says first 5 terms, we need 5 answers. So when I plug in 1, 2 to the first power is 2. And 1 factorial is 1. So 2 over 1 is 2. So that's our second term there. Next, I have 2. So I'm plugging in 2. 2 to the second power over 2 factorial. 2 to the second power is 4. 2 factorial is what? 2 times 1, which is just 2. So 4 over 2. 2. Next, a sub 3. I have 2 to the third power over 3 factorial. What's 2 to the third power? 8. And 3 factorial is 3 times 2 times 1. So 6. So 8 over 6. And how does 8 over 6 simplify? 4 over 3. So we have 4 terms now. We need one more. So a sub 4. 2 to the 4th power over 4 factorial. What's 2 to the 4th power? 16. And 4 factorial is 4 times 3 times 2 times 1. So 16 over 24, which is 2 over 3. Perfect. So those are our first 5 terms. So we can write our answer as 1, 2, 2, 4/3, 2/3. For the WebAssign, even though your calculator has a factorial button and you can plug all of this into your calculator at once, I need to see your work. So write it out. So here, on top, I have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, but I don't need to write it. On the bottom, you cannot multiply the factorials together. This does not become 12 factorial. It is 2 factorial, so 2 times 1, times 6 factorial, so 6 times 5 times 4 times 3 times 2 times 1. Now, if we didn't have a calculator, I could simplify my fraction before multiplying it. So if I have a 6 on the top, it'll cancel out with a 6 on the bottom. Same with the 5s and the 4s and the 3s and the 2s. Do I have anything else that'll cancel? 2 on the bottom goes into 8 4 times. So this is just 4 times 7, which is 28. Look, you're a genius. You don't even need a calculator. Another way you can write this, so kind of like a shortcut way of writing it out, is I have 8 factorial on the top. So this is 8 times 7 times 6 factorial. And I can stop there because I know on the bottom, I also have a 6 factorial. So on the bottom, I have 2 times 1 times 6 factorial. So since I have a 6 factorial on the top and a 6 factorial on the bottom, they'll cancel.
Could you cancel, like, how could you cancel out both of the 2's on the top and the bottom? And the only one on the top?
Because I took 2 out of 8. So I divided 8 by 2, and I was left with 4. The other 2 here canceled out with the one on top. Yeah, the second one here, the 2 goes into 8 4 times, so it's just 4 times 7. So it's just a different way of writing that first example. Now with example B, I watched Miss Meadows' video from last year and she skipped it. She was like, don't worry about it, but you guys are geniuses, so I'll write it out for you guys. So n factorial, if I wrote this down, it's n times what? What comes before n? N minus 1, because let's say 8 was our n. To get the number before, I just subtract 1 each time. So this is n times n minus 1 times n minus 2 times n minus 3. So we just keep subtracting each time. And I'll put a little dot, dot, dot. Well, on the bottom, I have n minus 1. So what comes before n minus 1? N minus 2 times dot, 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 dot. So what cancels? The n minus 1s, the n minus 2s, and then everything that comes after. So everything will cancel after that. So what's my answer? Just n. So last thing is summation notation. So it's this symbol sigma is what it's called. So the definition of summation notation is the sum of the first n terms of a sequence that's represented by this. So this number down here is our starting point, and the number up top is the ending. And we have to find everything in between and just add them all together. So I is our index of summation. N is the upper limit, so that's where we end. 1, or whatever it tells us down at the bottom, is our lower limit. So these are just some vocab words that you may see on WebAssign.
So we're solving for A.
So we're finding the summation, so we're adding them all together. So it's kind of the same thing that we did in the first example where we have to find the first 5 terms or whatever it is that it asks us to, and then we just add them all together instead of listing it as a sequence. The top number, the ending. So you start with the bottom and work your way to the top. So looking at example 8, what number do I start with? 1. So I start here.
Does the I equal just throws off?
It'll always be like I or K or J, and it'll tell you what to plug in here.
Okay.
So it's kind of like N. I think it could also be N, but it'll always tell you what to plug in into the equation. So I'm starting with 1. What number do I end with? 5. And then I have to find everything in between. So I find 1, I find 2, 3, 4, and 5. So first thing I'm going to do is plug in 1. So I have 3 times 1, which is 3. What do I plug in next? 3 times 2, which is 6. Then I plug in 3, so 3 times 3, 9. 3 times 4, 12. And 3 times 5, 15. And then I add up all of these numbers together. And that's my summation. So 3 plus 6 plus 9 plus 12 plus 15, 45.
I've never seen
All right, so with B, what number do I start plugging in? 3. What number do I end? 6. So in between, I'm going to plug in 4 and 5. I always like to write it down on the side. That way I know what I'm plugging in. You don't have to, but I think of it as like a check mark tally list. I know I have 4 numbers here, so I'm going to plug in 4 different things and add those all together at the end. So start with plugging in 3. I have 1 plus 3 squared, which is 10. Then I have 1 plus 4 squared, which is 17. 1 plus 5 squared, 26. And 1 plus 6 squared, 37. And add them all up together. Bless you. 90. Yep, 90. Yes. Yes. So again, you guys can use your calculators for all of these, but just make sure you are showing your work. All right, so there's one on the WebAssign where it's a summation. Let's say it started with I is equal to 1 and ended with 3. And the number was 4. Do I have an I in my equation to plug in here? No. But let's say I plugged in 1. What's my answer? 4. I'm going to plug in 2 because that's in between. So I plug in 1, 2, and 3. So when I plug in 2, what do I get? 4. If I plug in 3, what do I get? 4. So then we just add them together. 12. Yep. So there's one on the WebAssign like this.
Is it always just going to be the size number times the top number?
If you start with 1, it will be. But if you don't, it won't be. Because here we have 3 4s. If you don't start with 1, let's say I started with 0. Then when I plug in 0, I get 4, so that's another 4. So it's not just the first 2 numbers multiplied together. It's like how many numbers you have that's multiplied by the constant.